This is Sandeep Kolipara, and this is my project demonstration for my course Advanced Topics in AI. And the project title is LLM Agent for Interactive Data Analytics. And without further ado, let's dive in. So let's start with the code repo here. So on the right is the Git repo, and on the left is a local version of it, the clone. And I'm going to be operating on this with the motorcycle dataset from Kaggle. So this has basically some information about the motorcycles, their information regarding their owners and the previous prices and the kilometers it has driven. And yes, the target is the selling price for this dataset. So uh, I'm going to download this data set here, and I'm going to basically use this right now in our demonstration. So this file bike details is basically our uh, input, and we're going to paste it in this file folder called bb. So yeah, I've already pasted this here, and as you can see here, uh, we are ready to go. And before any further, let me just explain about the output folder. This is where the output is going to be generated once we are through. And there is information regarding the Python environment setup in this environment file, environment YAML file, and you can basically activate the set up this environment using Conda environment setup. So uh, yes, and the configuration is that we are using GPT-O as our LLM for this, and yes, that's our setup. So uh, without further ado, let's start. So this is the VS folder for the same exact repo, and let's lock in. Let's just zoom into our console here so that we can start. And I'm going to start with the Python source run. And the first agent that you will be looking at is the loader agent, and it has two functions: identify and load file, save data to file. The first one identifies and load files from the bb directory, and the second one outputs the file to the out directory. And let's load the file bike details. And let's give some supporting information, because the loader agent takes some information alongside it and it provides it to every other agent, such as this information here. And this can be even more descriptive of the data here. As you can see, it has successfully loaded the file, the bike details, and as you can see here, there are some null values in this column X showroom price. That's not a good thing, and that will be addressed by our next uh, the next functions, the next agents, exploration and the cleaning. So exploration agent is basically it can be used for conducting univariate analysis and any type of exploration, EDA, visualization. Basically, it calls the LangChain's pandas data frame agent. It is useful for exploring a static data set, and that's what we are doing here. Here it got us the descriptive statistics of the numerical columns here. So it's showing that there is this, so the showroom price, let's check how many nulls are there. So what are the nulls in the data? So there are 435 nulls for the X showroom price column, and let's treat it using the next agent, which is the cleaning agent. Cleaning agent has an assortment of functions here, ranging from eliminating constant features, high null features, identical features, high zeros features, features with very less variance, ID features, which are basically high non-numeric unique values, correlated features, missing value treatment, outlier treatment. We're going to be dealing with the missing values, so we're going to use the missing value treatment. So apply missing value treatment to data, and we can see that the showroom price has been now replaced, the nulls have been replaced with the average of the entire column. So that's the null value treatment using the cleaning agent. Let's go to the scaling agent. We have a set of numerical values here, right? Numerical columns. So let's apply scaling, scale the data. And what scaling does is basically, let me just go through the functions here. It identifies the numerical features using this function and then either standardizes it or normalizes it based on a normality test. Normality test is basically here what it applies the normality test on the columns, the numerical columns, and it gives out a p-value that p-value for the test that the feature is having a non-Gaussian distribution. So if the p-value is higher, it means that the distribution is non-Gaussian, which is not the case here. The p-value is perfectly zero here. Uh, yeah, so the p-value is perfectly zero, and it has basically reduced that and applied standardization to the data. And as we can see, it has basically standardized these data on the left hand side, the selling price, year, kilometers, and the showroom price. So this is scaling, and now let's encode the data for the categorical variables. And as we can see here, for encoding, what it does is, so if for encoding, the function gives this information to the LLM. Basically, it gives the categorical names, the features, and the classes within the categorical features. So it will have an idea of what the features contain, and using that information, it's going to deduce if there is any features that have like a hierarchy or ranking within them, and based on that, the encoding agent applies these functions. It identifies categorical features and then it applies label encoding or one-hot encoding. So label encoding is used for the ordinal types, the features like in our case, the owner feature here has the ordinality that the first owner is less than second owner is less than third owner is less than fourth owner, which is basically the how many owners that this vehicle has had previously. So that it has deduced from the data and it has applied label encoding. It's calling it ordinal encoding, but yeah, one hot encoding is applied to the name and seller features. Now as we can see, the name is not a, it's an ID technically in our case, so it should not be present here in our data set. So if we want to remove this, we now have to remove like all the features that are there. So 284 columns, from 7 columns to 284 columns, it has encoded the name, and this is not desirable. So what we can do is we can basically go back to the previous state before the encoding, and what it does is basically now if we check the columns in the data, we're going to get that this is before the encoding has taken place. So uh, we don't have the name feature blowing up the entire feature space. So what we can do is we can drop the name column here. So now we're coming to the feature selection. We kind of skipped out on dimensional reduction, but yeah, the feature selection agent takes care of selecting features, dropping features, and also it does feature selection techniques like random forest analysis and backward stepwise linear regression. And now we have basically like dropped the name, and uh, the router agent has called the feature selection agent, and feature selection agent has basically dropped the name column, and that's what's happened. So now we can safely encode our data without it blowing up our feature space like before. So yes, there is this rewind feature that I have implemented, so we can go back to the past states and the past data states as well. So it's a handy tool for a human in the loop workflow that we have here. And now we can see that the ordinal and the nominal types are treated accordingly, the owner and the seller type. So let's go to the next, which is the feature selection. Since we are here, let's apply random forest analysis. Now, if we apply random forest analysis, we're supposed to give a target. So let's give selling price as a target. It's gonna ask for it if we don't provide it as such. So yeah, it has already considered selling price from our partial information here. So there is this inbuilt like the information where it already receives the information about the current columns in the data. You don't have to worry about being accurate with all of your commands. So it is currently undergoing random forest analysis. Oh, it's already done here. So this is the variance importance, variable importance, feature importance, or Gini importance. And basically it shows that these three features have more energy than the entropy than the others, and they are more important. So if we were to basically select out of these five, we have to choose the three, and it has done so automatically based on the this information. So the agent is given the exact values that are there in the graph, and it basically differences them and finds the point where there is the highest drop, which is after the kilometers driven from 17 to 1, and it selects all the features before it. So this is the feature selection agent, and using the random forest, we can do one step further. We can also apply backward stepwise linear regression. So uh, we have to again mention the target, which is selling price. So unlike random forest, here it basically fits the model into a linear regression model, and it basically reduces these, which are the r squared values of the feature. So it basically drops the lowest fitting feature one after another. So it's basically dropped seller type, then owner, then kilometers driven, and then year, and then ex showroom price. And as the features are dropped, the r squared value drops, and we can see that after the year, the r squared drops pretty sharply to 56. So as you can see here in the data, so it calculates, differences it, and it calculates the point, and it basically returns that the first four have to be dropped, and only one has to be kept. That is this feature. So that's the linear regression model, the backward stepwise linear regression feature selection mode. Now there's one last feature, that is the dimension reduction, that's principal component analysis. There is linear discriminant analysis, but we can't use it because our target is continuous, it is not categorical. So before doing PCA, let's drop our target, which is selling price, and it's going to call the feature selection agent again, and now we just have our feature matrix here of 5, and let's apply PCA with max components, which is going to be 4. So uh, here we're going to have our, yeah, so this is our PCA output. So it basically has these so what we can see here is that almost 90% of the variance is provided by only 3 features. So if we were to select the features using this, we will have to basically select the first 3, and yeah, by default it applies a 95% cutoff on the cumulative variance, and based on these outputs here from the graph, we see that the first 3 features are to be selected, and yes, so that's the case. Now obviously we can't use this transform data, so knowing this, we can select the features manually, but for now let's just go back and let's save the file. Let's save the file as features.csv, and we should have it here in the output. And that's my demo. Thank you.